Okay, so we've got a question here about graphs of proportionality, and basically we need to remember that direct proportion is always linked to this idea that if two variables are directly related, then they're linear, and it's always going to be a straight line relationship, go through 0. If it's power 1, if it's power 2, then it's still going to be an increasing relationship, go through 0. And so if it's inverse, then y is proportional to 1 over the variable, so y equals a constant divided by x, and basically it's saying as one variable increases the other will decrease. So inverse relationships will be something over x, and going as one variable increases the other one goes down. So those are the kind of relationships we look for, and it's asking us to relate these. So this one's an inverse relationship. So this is going to be y equals k over x, or y is inversely proportional to 1 over x. This one's going down too, but it's got a positive bit here and a positive bit here, so that's going to be squared. So that's going to be related to 1 over. It's an inverse relationship, but it's a squared relationship because everything's been turned into a positive. This one's a direct relationship because as one variable increases, the other increases, and it's going to be proportional to x squared. This one's a linear relationship going through 0, so it's going to be y equals kx, or y is proportional to x. Okay, so those are the relationships, and the question says which graph goes with which. So y is directly proportional to x. Well, that was this one here, so that's graph D. Y is inversely proportional to x. That's that one there, so that's going to be A. Y is proportional to the square of x. So proportional is as one increases, the other increases as well. So that's going to be B. And y is inversely proportional to the square of x. Well, inverse to the square means everything becomes positive on the y. So that's going to be graph C. Okay, so that's how that question could be answered, by thinking about the relationships and the way the graphs are. Okay, so this was the straight line, this was the inverse proportional, this was to the square of x, and this was the inverse, but both of them on the positive side for y. Okay, so that's how that question could be answered. Alright, so we've got to prove congruent. Okay, so proof requires you to be very clear about what you're doing, so and why you're doing it, so you need to explain. So let's have a look what they're telling us. PQ is equal to PR, so PQ is equal to PR. Well, this tells us then that we're dealing with an isosceles triangle. S is the midpoint of PQ, so S is the midpoint of PQ. So this tells me that that length and that length are identical. And T is the midpoint of PR, so it tells me that that length is identical to that length, that is identical to that length, is identical to that length, because they told us that PQ and PR are the sides of isosceles triangles. Okay, so we know that those lengths are all the same. It's an isosceles triangle, so that means that the whole of that angle must be the same as the whole of that angle. And okay, so let's see what else. Right, so we've got to prove that QTR. Alright, so QTR and RSQ. RSQ. Right, okay. So, well, straight away then, if we look at the two triangles, so we've got QSR. Well, we know that that length is that, and we know that QR we defined as that length. Okay. And SQR, well, we know that that's the angle there. Alright, and if we draw the other triangle the same way round, so we can compare them, that would be T, that would be R, and that would be Q. We know that TR is that length there, we know that RQ is that length there, and we know the angle TRQ is the same as this one here. Okay, so we know that when a question talks about congruency, then when it's talking about triangles, we're either trying to prove that it's an SS triangle, an SAS triangle, an RHS triangle, or a angle side angle triangle, or the angle angle side. Okay, so when we look at this, then we can see that we definitely have a side angle side, side angle side. Alright, so we're going to prove side angle side. Alright, so that's what we're going to prove. So we need to say why, because it says proof. So let's have a look at this side here then. So QS and RT. Right. So QS equals RT. Both half the lengths of an isosceles triangle where PQ equals QR. Alright, angle. Okay, so PQR angle equals PRQ angle, which is equivalent to saying SQR equals TRQ, base angles in an isosceles triangle are equal. Okay, because we knew that PQ is equal to PR, telling us it's an isosceles triangle, PQR, then we know that angle PQR must equal PRQ because the base angles in an isosceles triangle are equal, which is equivalent to saying that SQR is the same as TRQ. Okay, and then the third side, well, QR is a common length to both triangles. Both triangles QTR and RSQ. Okay, it's a proof question, so we should finish off with that sentence by saying hence QTR, triangle QTR and triangle RSQ must be congruent as SAS holds for both. Okay, so we just need that sentence at the end when we do a proof question. So just remind ourselves then, so we had this triangle here. From the information we knew it was an isosceles triangle. Because they told us these midpoint things, then we knew that both those lengths were identical, and we know that QR is common to both shapes. Drew out two separate triangles that we're trying to prove a congruent, so I could see how the lengths fitted. We could see that we had a side angle side triangle, side angle side triangle, so that's the one we'd prove. Okay, there are lots of ways of doing that one. You could have done side, side, side and various other things as well by different language, but side angle side was probably the easiest one to go for in this particular question. Okay, so this question talks about a solid hemisphere, so we must remember that means half the sphere. It's solid. It's telling us the volume of the sphere is that, so it's telling us the volume of the hemisphere is that. Well, if we know the volume of the sphere is that, then a half of that, which is 2/3, so this is equal to 2/3 pi r cubed. Okay, because the volume of the hemisphere is half the volume of the sphere, so half of 4/3 pi r cubed is that. Work out the exact total surface area of the solid hemisphere. Okay, so this is telling us then that we would need to do 4 pi r squared for the total sphere halved plus pi r squared for the circle. Okay, so we know that that's going to be r, this is going to be 4 pi r squared over 2, and this is going to be pi r squared. Alright, so that's what the information is telling us. So it seems to me that the missing thing here is, what's the value of r? Well, solve this, we can find r. Okay, so let's go for it then. So we divide by pi, then we're left with 250 thirds equals 2 thirds r cubed. If we times by 3, then we're left with 250 equals 2r cubed, and then if we divide by 2, we're left with 125 is equal to r cubed, and then if we cube root, we're left with 5 is equal to r. So we have r is equal to 5 centimetres. Okay, so that was a fairly straightforward manipulation of the known facts. They told us what the volume of the hemisphere was. We know the formulas for the volume of a hemisphere, and then we can just rearrange by doing the opposite operations to find out the value of r. Once we know the value of r, then that goes into here to allow us to calculate the answer we need. So we have 4 divided by 2 is 2. So it says gives the answer as a multiple of pi, so I don't have to use pi, just need pi on its own. So that's 2 times pi times 5 squared plus pi times 5 squared. 225s are 50, so that's 50 pi plus 25 pi, so in total it's 75 pi. Okay, so that's the answer then, 75 pi. Square centimetres of course, because it's about things, so that's what goes down on the answer line. Alright, so this question then, when you work it through, use known facts. This is what we know to find out the value of r. Once we know the value of r, then we can again use formulas by writing the formulas down, filling in the known numbers, and then we can work out the answer they wanted. And it is in a multiple of pi, 75 pi's. Okay. Alright, so we have a question here that says simplify this. It's got square roots in it, so this is about surds. Okay, so we know the rules of surds say things like the square root of AB is equal to the square root of A times the square root of B, and we can simplify down by finding other things. So this is an expansion, isn't it? So we've got to expand that. So lots of ways of doing that. So we've got 6 take away the root of 5 times 6 times the root of 5. So times in grid. So 6 6s are 36. 6 lots of root 5. 6 lots of negative root 5. So that's going to be negative 6 root 5. And then we've got root 5 times negative root 5, which makes negative 5. If you're not sure why that happened, then when you've got root 5 times negative root 5, it's the same as saying you've got the root of 5 times negative the root of 5 times 5, which is going to be negative root 25, which is equal to negative 5. Okay, third rule says I can put these two roots into the same root, so those two can go in the same root, the negative sign stays outside, so that's why we end up with negative 5. So when we bring this together then we've got 6 root 5s take away 6 root 5s, cancels nothing, and then we've got 36 take away 5. So this has now become 36 take away 5 is 31 over the root of 31. Now it says simplify fully, so you've got to be careful. That means we don't want a square root at the bottom. So we now have to rationalise to remove the square root on the denominator. Alright, so that means we end up doing 31 over the root of 31 times the root of 31 over the root of 31. Now the reason we can do this, of course, remember, is that that divided by that is 1. So we're just timing this by 1, which is going to change the way it looks. Times in the same square root, that becomes the number inside, 31. And then we've got 31 times the root of 31. Well, 31 divided by 31 cancels to 1, so we end up with a final answer of the root of 31. Okay, so that's how that question worked, by using the rules of one of the rules of surds. Alright, so this next question talks about drawing a cumulative frequency graph. So they're giving you an extra column here for a reason, because we'll need to work out what the cumulative frequency is. So up to 80 was none. From 80 to 100 plus those, there was 9. Plus that 35 was basically when you do cumulative frequency, you add as you go down to get the cumulative frequency, total frequency as you go down. So 9 plus 35 is 44, 44, 74, 80, 92, 100. Okay, so there's 100 films altogether. It says draw the cumulative frequency graph. So when we're drawing a cumulative frequency graph, we must remember that means we plot the cumulative frequency against, in this case, time for the films, and we'd expect the graph to ever be increasing until we reach the total of 100. Okay, must be going upwards and upwards and upwards. It's cumulative, it gets bigger and bigger as you go along. Alright, so up to 80 there are no films. 80 to 100 there are 9. So again, work out the scale. We can see that each little square is worth 2 going up there. Then we got up to 120 is 44. Notice that I'm plotting the upper bound of the interval. So 140 we've got 74. So 140 we've got 74. And 160, 92. And 180, 100. Okay, so it's really important when you draw these graphs that you recognise that you're always plotting the upper bound. Plot the upper bound. Okay, against the cumulative frequency. So we plot the upper bound for cumulative frequency. Alright, we need to obviously finish this graph off, so we ghost our line and then we go through every cross. Okay, that's the cumulative frequency curve drawn, and then it says estimate the number of these films with a running time of less than 2.5 hours. Okay, so 2.5 hours is 120, 150 minutes. Okay, just remember this is in minutes, so we need to turn the thing to 150. So we get our ruler at 150. Come across. Okay, and it says with a running time of less than. Alright, so less than means we want all of these, because all of these have got less than that. So for my graph it's 84. Your graph might be slightly different, it depends on how you've drawn your curve. Everybody will have a slightly different curve possibly. Okay, so just be careful because I was only just within half a square there. Ideally you go through every cross perfectly. Alright, so cumulative frequency, then you plot the upper bound of the interval against the frequency, and then we can read off the graph.